Hello everyone. In this lecture, we will see how to design a 3-bit down counter synchronous circuit using D flip-flop. So here we will follow 4 steps to design such circuit. First one is draw the state diagram. Second one is the state table. Third is the K-map to find out the inputs of D flip-flop. And the fourth, we will see the circuit diagram. So in the normal way, I can explain down counter, 3-bit down counter that counts in a downward direction. That means it will count like this: 7, 6, 5, 4, 3, 2, 1, 0, again 7, right? And then so on. So for such circuit, if you want to draw the state diagram, convert into the binary form. That's it. So here we have 1, 1, 1. That is the representation of 7. And then the next number is 6. You write down 1, 1, 0. This is the binary form of 3. Then after that, next state will be 1, 0, 1. Next state will be 1, 0, 0. Next state will be 0, 1, 1. That means 7, 6, 5, 4, 3, then 2, then 1, then 0, and then again 1. Got it? So this is called as the state diagram. Now by using this state diagram, we have to draw the state table. So now here we will draw the present state in the state table. I'm talking about the second step. In the state table, there are some parameters. First one is the present state, next state. Then here, if you are considering 3-bit up and down counters, then there will be 8 possible combinations, right? So here I am assuming this is QC, this is QB, and this is QA for these 3 bits. So as we are considering 3 bits, total 8 possible combinations will be there. Now this is 0, 0, 1, 1, 0, 0, 1, 1. Just I am writing all the 8 possible combination for 3 bits. Now we have to find out the next state. What does it mean? If you are in state 0, 0, 0, that is your first combination, 0, 0, 0, what will be the next state? Next state is 1, 1, 1. And how we will represent it? We will represent as QC plus 1. This is QB plus 1. And this is QA plus 1. Clear? Now, for every bit, it's the decrement order, right? If you are in at 0, 0, 1, 0, 0, 1, next state will be 0, 0, 0. So 0, 0, 0. If you are at state 0, 1, 0, next state will be 0, 0, 1. If you are at 3 state, means state with representation 3, then the next state will be 2, 3, 2, 2, 0, 1, 0. Clear? Similarly, for 4, the next state will be 3. For 5, it will be 1, 0, 0. For 6, it will be 5, so 0, 1, 0, 1. And for 7, it is 1, 1, 0. Now we have the next state and present state. For example, you want to draw the circuit by using the D flip-flop. So for that, we require the excitation table of D flip-flop, and excitation table of T flip-flop will be given as Qn, Qn plus 1, and here we have T, 0, 0, 1, 1, D flip-flop. Okay, as we are using here D flip-flop, we require the D flip-flop. 0, 1, 0, 1. If you are using the T flip-flop here, that means we require the excitation table of T flip-flop. 0, 1, 0, 1. With the D flip-flop, the good thing is what? The value of next state is similar to that of D. So here, if you see, to find out the value of DC, DB, and DA, just note down the same thing of the next state here as DC, DB, and DA, because whatever will be the next state, it will be similar to that of D that we have checked by using the excitation table here, right? So now then whatever was the QC plus 1, it will be similar to that of DC. So it's what 1 0 0 0 0 1 1 1. I just written same thing whatever is there at QC plus 1. Similarly, for dB, you have to write down QB plus 1. That is 1 0 0 1 1 0 0 1. Similarly, here it is 1 0 1 0 1 0 1 0. Now we have this state table with us. For the third step, we have to draw the K map. So now K map, how many variable K map is required? As this is the 3-bit down counter, so we have to make a 3 input variable K map. Here we have present state as QC, QB, and QA. So we require 3-bit K map for finding the value of DC. So I am drawing the DC here with 3 variables. Here I am considering QC, here I am considering QB and QA. This is 0 1, this is 0 0, this is 0 1 1 1 and 1 0 because it's following the gray code. Now wherever your DC was 1, you fill it here. DC is 1 here, that means it's 0 0 0. Next is 1 here for 1 0 1. Next one is here for 1 1 0 and then 7. So 0 5 6 7 0 5 6 7. So this is 0, this is 5, this is 6, this is 7. Now we have this data with us. Now we have to make the group to write down the expression. So now here we can make one group like this, one group like this, and one individual term. So now I can write down the expression for DC. For this individual term, we can write down as QC bar, QB bar, QA bar. For this a group, we can write down as QC, QA plus. For this group, we can write down QC, QB. So this is the expression for DC. Similarly, we have to write down and make the K map for DB. For DB also, we have to make the 3 variable K map because here also the inputs are same. That is QC, QB, and QA. 0 1 0 0 0 1 1 1 1 0. It's also following the gray code, right? So now wherever your function value of DB is 1, for that you write down in the K map 0. Here it's 1 for 0 0 0. It's 1 again for 0 1 1 3, right? So 0 3 4 and this is 7. So 0 0 3. So it's 0 3 4 and 7. Now here also we can make a group, and this is one group and this is the another group. So we can write down the expression of DB as QB bar QA bar plus QB QA. Similarly, we have to find out the expression for DA. So DA will again have a 3 variable K map like this. This is 0, this is 1, this is 0 0 0 1 1 1 1 0. It's following the gray code. Now wherever your DA is 1, you fill it here also. So here it's 1 for 0 0 0, again 1 for 0 1 0, again 1 for 1 0 0, and again for 1 1 0. The same thing I have to fill it here also. So this DA is 1 for 0 0 0, again it's 1 for 0 1 0, again it's 1 for 1 0 0, and then 1 1 0. Here also we can make a quad and we can write down the expression of D as QA bar. Now we have all the expressions here. I am writing all the expression and then we will make the we will make the circuit diagram. So DC is equals to QC bar QB bar QA bar plus QCQA plus QCQB. Similarly, DB will be given as QB bar, QA bar plus QB, QA. Similarly, we have calculated the value of DA as QA bar. Now here we have to make the circuit diagram. So this is a D flip-flop, 1, 2, 3. Always remember all are D flip-flop, but the most significant bit will be the last one. Here you can write down the MSB. This is B and this is A. In the DA, we have to provide QA bar. Here in DB, we have to provide these two values. So here you make two AND gate. Along with that, you make one OR gate, and here you attach it like this. Here you provide QB bar, and this is QA bar. Similarly, this is QB and this is QA. The same as we got expression. Similarly, here for DC, it is 3 AND gates, 1, 2, and 3, and all will be given to one OR gate, and that will be given here. Here we have to provide QC bar, QB bar, and QA bar. Similarly, here it's QC, QA, and here it's QC, QB. Similarly, as you know, this is a synchronous circuit, so we have to provide the same clock to all the flip-flops. So here I'm providing it like this. Here, as this is a D flip-flop, you will get QA output. Here you will get QB output. Here you will get QC output. And this is the circuit for 3-bit down counter synchronous using D flip-flop.